Hello, thank you for joining our webinar. On our webinar today, we'll give an overview of exploring multi-cloud architectures given by Penguin's Director of Cloud Services, Cottay. We will wait until the end of the webinar to answer any questions you have. With that, we'll talk to you about the exploring multi-cloud architectures.
Thank you, Ken. And thanks everyone for coming today. We will talk a little bit about multi-cloud architectures, but I want to remind you what we talked about a couple of weeks ago when Matt started this webinar series. He talked about what's driving the adoption of Cloud 2.0 and how is that different than Cloud 1.0. He talked about how we're seeing our customers shifting from a cloud first to a cloud appropriate way of doing things. And also how people are starting to think of computing as a continuum. They're not thinking about a location where their computers are. They're not thinking about where their applications run. They just think about applications and running their applications. Today, we're going to talk a little bit about the different sorts of cloud architectures that people are using now, mostly through case studies. So we'll talk about multi-cloud, hybrid clouds, and private clouds. Again, we'll talk about some case studies. And then we'll talk a little bit about what you need to consider when you're designing this sort of workflow. So first, we'll talk about multi-cloud. Multi-cloud, or as some call it, polycloud, is the use of multiple clouds in a single workflow. The biggest reason people do this is to select the right resources for each step in the workflow. Maybe one cloud provider can provide good GPU resources. Another cloud provider can provide high performance computing resources. Another one can provide good database access or data distribution tools. This, when you build it, you have to remember that it gets spread over multiple cloud environments. So each one of those needs to be architected, maintained, and everything you have to do with each environment. The case study we're going to talk about here is one of the earliest, is one of our customers at Penguin. And they're one of the earliest adopters that we know of for a true multi-cloud architecture. It's a very large multinational engineering firm, but they've got a very small group that does earthquake simulations, mostly for buildings, but sometimes for things like dams and things like that. And they're geographically removed from the rest of the company. They're in a very small office and really don't have the resources that this big company has. This company also doesn't have the sort of resources available that they need to use. So they use LS-DYNA, which runs very well on high-performance computing clusters and scales very well. And they also use OpenFOAM, which also scales very well on a traditional HPC cluster. However, traditional HPC clusters were not appropriate for some of the other steps in their workflow. So when they first realized that they couldn't run on their local machines, it was taking days and days and days to run a simulation, they started running simulations up on Penguin's cloud. And it was very labor intensive. So they'd build their models, they'd upload it, they'd log into Penguin, they'd do their simulations and maybe a little bit of post-processing. Then they'd download it, some of the results. They'd then upload it to Google to use the TPU resources there to do the rendering. And then they'd bring those results back and then they'd put them out on Amazon Web Services to distribute to all their users. Well, that worked, but engineers were spending more time moving files around, waiting for files to get moved around, and doing the sort of work that they really didn't want to be doing. They wanted to be doing engineering. They didn't want to be doing data management, essentially. So they started building a multi-cloud workflow. Now with this, the engineers still build their models locally and set up the simulations, but then they have pieces of software they've written that do the entire rest of the workflow. So it uploads the simulations to Penguin's cloud pod. The simulations get run there automatically. They have software that looks at the results of the simulations and decides which one is the best one to present to their engineers. They then render the results on Google automatically, both video and still pictures. And then those results get automatically moved to their content distribution network that they have running on AWS. This has really freed up all their engineers to do engineering instead of doing data management and data movement and worrying about how that all works. Now this was very hard for them to do because this is fairly early in the process. Not many other people were doing this. And to get this running smoothly, it was a 2 or 3 year journey for them. But what they ended up with was well worth it. They weren't able to build out clusters. They would have had to get a data center and build a cluster. And they don't have to do that now. They've got a seamless automated cloud workflow. Again, they don't have to pay any attention to it whatsoever. They do their engineering, building their models, and everything else is automated. And they're able to optimize their costs. Again, using the cheap TPUs on Google and using AWS to distribute their results worldwide, and using the proper resources for doing the simulations. Another cloud strategy that everyone's talking about these days is hybrid cloud. And hybrid cloud is really the idea that you've got resources on site, on your premises, but they're either not the resources you need necessarily. Maybe there's other things you need, large memory nodes, things like that. Or it's not as large as you need for peak loads. So with hybrid cloud, you would normally run most of your processing locally for a good portion of it. And then you would, when you need more, you'd use cloud services to do it. One of the companies that was early in doing this and is still doing it, it's a small weather company. They've got some unique talents and unique models that they use to predict tropical storm and hurricane tracks. They sold those services to a large reinsurance firm because, of course, the reinsurance firm really has a lot on the line when a hurricane is forming. The problem is that on premises, they've got enough resources to track 2 hurricanes or 2 tropical storms, which is typically what you see in hurricane season. Sometimes it's there's a few more than that though. Like this year, when we tied the record of having 5 active storms in the Atlantic Basin. So what they really can't justify purchasing the hardware to do that because that happens once every 10 years. It start happening more often now. But historically, that's happened once every 10 or 20 years. And so they really can't justify buying the resources to do that. And so what they did was use Penguin Computing on Demand, POD, as a secondary resource. There they had the ability to go in and set up exactly the same environment that they have locally. Their software runs exactly the same. And all they really have to do is, when they need it, log in, pull the data from NOAA to the current data, and track the storms there. That gave them the ability to actually be the sole provider for this large reinsurance company, which they wouldn't have been able to do otherwise. So what they got is an as-needed, pay-per-use resource. They don't pay a thing when they're not using it. They just pay when they need it. They didn't have to purchase more resources locally. And while it's not an endlessly scalable resource, they could easily model 10 or 15 storms at a time there. The other thing we're seeing quite a bit of with Penguin is a private cloud. Now, that private cloud might be on premises and shared out over just the internal use for that company, or it could be in another cloud environment. So generally, it's an isolated single-tenant cloud. This gives you the flexibility of cloud, the ability to burst out, for it to be larger and smaller, to shrink your resources and grow your resources, but gives you the security of a dedicated resource. One of our customers that does this is a startup, and they've got a Fusion Reactor that they run, and they generate a lot of data from that. There are sensors and instruments all over there. And they don't have the resources or the knowledge to support an HPC cluster to do the sort of data analysis they need. While they could do that, they really don't want to spend their resources on that. They don't want to spend their time on that or think about running that. So they wanted to go to a cloud resource. However, no matter how demonstrably secure that resource was, their research is very sensitive and their data is extremely proprietary, and their board would not let them use any cloud resource. So what they've decided to do is use a dedicated cloud resource. So they're running in a high security facility. They have access to compute resources that no one else can see. They have access to storage that no one else has access to. They get the benefits of cloud in a few ways. One, they don't have to run it. They don't have to know anything about it. They just need to run their applications. They can grow the resource when they need to. If they're going to go back and do reanalysis of a lot of data, they can add more nodes to that resource and then take them back out when they're done. So they're really only paying for what they need when they need it. And they can provide other people with access to that cloud. Over the course of their experimentation, they've needed various data scientists to have access to all that data. Some people look at it one way, some people might look at it another way and use different techniques. Because this is already in a cloud environment with secure access, they're able to provide access to these data scientists who can go in and work on the data. And then when they're done with the tasks that they're working on, they can turn off their access. So what they get is the flexibility of the cloud that's in a private, very secure data center. They didn't have to get any hardware or get any sysadmins. They could set up a stream to stream the data from their instruments there over secure links. And while the slide here says that they get an on-premises level of security in the cloud, they actually get a much higher level of security than one would expect to have in a typical on-premise environment, because it's in a very highly secure data center. So these are some pretty simple examples, and maybe you think about what your workflows are like and how you may want to take advantage of some of this. But you have to realize that there are a lot of things you need to consider when you're going into a multi-cloud environment like this. You have to think about where your data is, where you're going to generate the data, where you're going to use the data, how you're going to move that data around, how do you control that data? So that's one thing to keep in mind, because that's definitely something that trips a lot of people up, because data does not move instantaneously. You have to think about how to make your workloads portable, hopefully, because maybe you want to use AWS and Pod right now, but then your company makes a great deal with Azure, and you want to use Pod and Azure, for instance. If you're using workload portability techniques like containers, you're able to do that fairly easily. For some workloads, that's very important. For others, it's not so important because you need a particular resource. For instance, in HPC, some people are using container technologies in HPC, but for the most part, they're using those clusters because they are exactly what they want. And if they move somewhere else, they're going to move into a very similar environment. However, you still need to think through workload portability. The other is, if you're using many resources at the same time, you're going to have to automate your workflow, because otherwise you're going to be most likely be spending too much time orchestrating this by yourself. So you can, in next webinar, we'll be talking about some of the tools you can use to automate your workflow. We're going to be talking about some of the tools that you can use to move data and actually to enhance workload portability also. But think about how that works before you do it, and go through all the steps that you know you're going to have to do and see if you can automate them. If you just try to do them manually, it usually doesn't work out very well, let's put it that way. The other is look at the cost. See whether it really benefits you or not. I mean, maybe you're better with a in-house system. Maybe you should be confined to just a couple of resources. Or maybe there's benefits, like there were for the engineering company, of using multiple resources at the same time for a workflow. The next thing to remember, and really should be the first thing on your list when you're thinking about all these other things, is security. I mean, every day you hear about people with unsecured S3 buckets and losing all their data and that sort of thing. Every one of the environments that you're going to be running in handles security in a different way. And you have to make sure that you understand that and understand how to manage security in all those environments, and how to really find out how secure the environments are that you're working in. And part of that is leveraging external personnel. You can't expect your IT department to know everything about every cloud resource there is. But there are people that do understand each one of the different cloud resources, how the security works, how the data works, how everything there works. And those are the people you need to leverage. Because someone understands AWS does not mean that their knowledge is going to immediately transfer to running on Pod, for instance. So you need to make sure that you can leverage the appropriate personnel to build this architecture and actually monitor it and keep it running. So I know that was pretty quick. And I want to see if we have any questions. I'm trying to find the questions here. Oh, here we got a question that just came in. Can Penguin help people build these workflows, or do you just provide hardware or cloud resources? I probably should have mentioned this. Yeah, Penguin does do this a lot. We're very skilled and familiar with doing this. These three companies we worked with on our cloud environment, and we work with people on a regular basis on our cloud environment. We also work with our hardware customers to put together resources like this, whether they're internal clouds that can burst out to other clouds, and workflows that can span multiple clouds inside an environment. So yes, Penguin's a very good resource for putting together workflows like this. Do we have any other questions? Oh, here, finally the Q&A came up. What are the challenges around data locality when trying to build a multi-cloud strategy? Matt, who gave the webinar last week, likes to talk about data gravity. Data wants to stay where it is. If your workflow requires you to move that data around, it can really impact the amount of time it takes to get to a solution. There's solutions that we're familiar with now and that we're working with now that we're going to talk about in the next webinar that make that a little bit easier, make it easy to access data remotely. But really that is a prime consideration about how you build a workflow like this. Here's another question. You said the use of private cloud did not need to spend money on hardware or IT staff. Where does the private cloud hardware exist? In this example, this is in a Penguin data center where we have other cloud resources that's segregated, it's physically separate, and the network is completely separate from our cloud resources. And typically that's what you'll see. You'll see these private clouds go into public data centers. Who should we contact about getting help with the workflow design? If you're working on pod, we can help you by just sending an email to pod@penguincomputing.com. If you're looking at hardware and want to talk to, or just looking at services, you could go to the Penguin website and request someone there contact you about that. And I believe those are the last of the questions. So our next webinar is going to be in, whoop, wait a minute, I've just heard that there are 3 more questions. Oh. What are the unique features of Penguin Cloud HPC compared to the others available on the market? And this is not a Penguin employee that is prompting me to sell pod. Pod, Penguin Computing on Demand, the biggest difference between that and a traditional cloud provider is that it's purpose-built for HPC. It's built by HPC experts, and it uses all the traditional HPC techniques. In other words, we're running on bare metal. We're running tuned operating systems for HPC. We've got high-speed, low-latency interconnects between all the nodes for MPI jobs mostly. We have parallel file systems. And this is something you can find with some other vendors also. Biggest difference, that's the difference between, trying to run in AWS and building your cluster and that sort of thing, and coming to Pod where it's already built, the software's already there, ready to go. But the biggest thing that customers tell me they like about Pod compared to other HPC vendors is our service. We have a very high level of service. We score very high in customer satisfaction. And we try to really take an interest in what our customers are doing and help them do that. Another question, is it your bare metal that helps the private security? It makes it a little bit easier. We haven't had to worry so much about some of the attacks on Intel CPUs, for instance, because we never let two customers run on the same piece of hardware at the same time. In the context of a private cluster, it really doesn't matter if it's bare metal or virtualization or containerization or anything like that, because it's completely private. So unless Ken corrects me, I think we've answered all the questions now. Our next webinar, we're going to go into more detail with this. We're going to talk about some of the technical ways that you solve some of these problems, how you solve the data locality issue, how you solve building, maintaining complex multi-cloud workflows. We'll talk a little bit about remote visualization and why that's important and how to do it. And we'll talk about that in the context of both on-premises and private cloud. Thanks so much for attending. I really appreciate it. And I'll turn this back over to Kim.
Thank you, Will. Thank you for listening to our webinar today. I just want to inform you that the webinar today was just the second series of our 3-webinar series on navigating the clouds. Please join our upcoming webinar on taming multi-cloud workflows on October 13th at 10 a.m. Pacific Standard Time.